a mathematical brain teaser that goes as far back as 1889. It was first introduced by a Frenchman named Joseph Bertrand. There are many variations of the puzzle, but for this example, we will stick with a game show, hence the name, the Monty Hall Problem. It was based on the show of Let's Make a Deal, and the host's name was Monty Hall. Suppose you're on this game show, and you have a chance to win a fancy new sports car. You're presented with 3 doors. All you have to do is pick the right one. Behind 2 of them, there's a goat, and behind the 3rd, there is a fancy car. Sports car. Let's say you select door number 1, but you don't open it yet. The host, who knows which door the car is behind, shows you a second door. When he opens it up, there's a goat behind it. This eliminates one of the options. He then asks you, do you want to keep the door you chose or switch for the 3rd option? Here's where it gets interesting. The answer is yes, you should switch your door. But why? To most people, it would appear that their chances of being right went from 1 in 3 chances to a 50-50 chance. But according to the laws of probability, this assumption is incorrect. That is why this problem falls into the counterintuitive category. Well, duh. The general idea is the more you know, the better your decision. If you switch doors, you will win 2/3 of the time. Here's why. According to the experts, the probabilities of your initial choice being correct and the remaining choices have to sum to equal 1. Therefore, the probability of the remaining choices have to sum to equal 1 minus the probability of your initial choice. In this case, with the 3 doors, they have to sum to equal 2/3. Say a door isn't opened, then you would have 2 to switch to if you chose to switch. This would be like changing your mind, and your chance of picking the correct door would be 1/2 of times 2/3. Well, that's a third, just like your initial choice. But if Monty opens a door, then you only have 1 door to switch to. In this case, which is the Monty Hall problem, you'll pick the remaining door. So that would be 1 times 2/3, and that's a probability of 2/3.
Listen, I did not say any of this makes sense. I'm an art major after all. I'm purposely not a math major because math gives me a headache, and this problem gives me a headache.
So I'll just take the experts' advice and assume they know what they are talking about. If I'm ever on a game show and presented with this problem, I will switch doors in order to win. But in all honesty, I'd probably rather have the goat. I mean, look how cute he is, and I never have to mow my yard again.